In the previous lecture, we had seen the working of four-stroke petrol engine. Today we will study the four-stroke diesel engine. This engine was invented by Rudolf Diesel in the year 1892. And the major difference between a spark ignition and compression ignition engine is that the ignition takes place at constant volume in spark ignition, which we had seen last time. And in this case, for diesel engines, it is at constant pressure in CI. In diesel engines, there are generally three valves: air, fuel and exhaust, inlet valve, fuel, exhaust, and also there is a high pressure fuel pump and the accompanying injector in place of the spark plug of a petrol engine. Now let us see the four strokes. This is the suction stroke. In the suction stroke, the air has to be, the air has to be inducted through the inlet valve. So the inlet valve will be open, the exhaust valve will be closed. High pressure air, only air, is inducted into the cylinder chamber due to the downward motion of the piston, which creates a suction, and the air comes in. This takes place from, let's say, if this is 0 degrees, 0 to 180 degrees. Half a full circle. The next stage is, as we know, is the compression stroke. Here the piston moves from the bottom dead center to the top dead center. Both the valves, the inlet as well as the exhaust valve, will be closed, and the air which was inducted during suction is compressed to a very high degree, raising its temperature to as much as 600 degrees centigrade, and even the pressure would be around 3500 kilopascals. So just as the piston reaches the TDC, diesel spray is injected through the injector and it self-ignites. Compression ignition. This is from where the word is derived. It ignites due to the high temperature and the combustion starts, which pushes the piston from the top TDC to the BDC. The last is the exhaust stroke. Then, for the fourth time, when the piston moves from the bottom dead center upwards, the inlet valve will be closed, the exhaust valve opens, and the pressure of the piston pushes the combusted products out of the exhaust valve port. We had studied the indicator diagram for the petrol engine. Let us have a look at both the ideal and actual indicator diagram for a diesel engine. 0 to 1 for the ideal indicator diagram. This is the atmospheric pressure line. 0 to 1 is the suction. 1 to 2 is the compression. 3 is the start of combustion at constant pressure. Pressure constant. After the mixture of air and diesel is ignited, the expansion stroke takes place and the piston is forced downwards due to this energy. The exhaust takes place from 4 to 0. The actual indicator diagram will display this figure. As before, the suction is always below atmospheric because the port is small, as I had mentioned earlier, and so that to quicken the pace of induction of charge, it is below atmospheric pressure, and then from 1 to 2 compression, start of combustion, and this is the exhaust. There's just some salient points to note. The diesel engine is invariably heavier for the same power of a petrol engine. The reason being that very high pressure is developed in a diesel engine, and it is for this reason that the engine block is much thicker and therefore much heavier than a corresponding petrol engine. Due to the high temperatures and pressure, the thermal efficiency is also high because the CR is high. We had mentioned that the CR of diesel engines anything between 12 and 22, and of course due to the more expansion. Now, having studied the 4-stroke diesel engine, let us move on to the 2-stroke petrol engine.